Let's start analyzing our data set characteristic by characteristic. ID. What does an employee ID tell us? Obviously, that's the individual identification of each person. This means that each number from this column represents a specific employee. Therefore, the identification number is the only information we have that indicates precisely who has been away during working hours. And this information is useful to have. It could help company management when monitoring the presence of each employee. However, will this information improve our analysis in any way? Actually, no. It will rather do the opposite. How would a value of 5 or 10 make a difference to the absenteeism time? The ID is just a label variable, a number that is there to distinguish the individuals from one another, not to carry any numeric information. It is nominal data. Should we let this column take part in our analysis, the subsequent computations will be false. Thus, ID can't help explaining the value of the absenteeism time. So, in such a situation, as researchers or analysts, what we should do is drop this variable. Why? Because, as we mentioned, it will certainly harm the precision of our estimations. Is this easier said than done? Not really. Applying this operation in Python is quite straightforward. Nonetheless, please note that it relates to a tiny peculiarity. To drop the ID variable from our regression equation, the drop method has to be applied to the data frame we've called df. Even more interesting is what is to be specified within the parentheses, though. We need to create a list indicating the names of all columns we'd like to get rid of. For the moment, this is just the ID column. So, within the parentheses, we must use brackets, and within them, we need to write ID within quotes. There's another really important thing to add here. As you can see, if we run this cell in its current state, we will get the error label ID not contained in axis. Why? Because unless we specify the axis along which we'd like to drop the element from our list, Python will assume we are talking about the rows of our data frame. And in our case, we don't have a row that's called ID. All our rows have been numbered between 0 and 699. So, after the list and still within the parentheses, we have to type comma, axis equals. If we type 0, the computer will search for a value called ID along the vertical axis. That's the default value, meaning that if we type nothing after ID, which is what we did a minute ago, Python will proceed just as if we had typed comma, axis equals 0. Instead, to show we are interested in removing a column from our data frame, which is information organized along the horizontal axis, we need to type comma, axis equals 1. Let's do this and then execute the cell to verify that everything flows okay. Most definitely. The ID column does not show up anymore. However, let's examine the content of the df variable to check if the ID column is still there. Yes, it is. Why? To prevent the mistake of permanently removing a column from the variable containing the initial data frame, when applied, drop delivers a temporary output. Translating this to our example means that, for the moment, the content of the df data frame isn't reduced. To do the latter, one must take advantage of an old programming technique. You can assign the expression containing the drop method to the df variable itself by typing df equals and then state the relevant expression. Executing this line of code will overwrite the content of the data frame, and when we check df after that, we won't see the ID column anymore. Is it so? Yes, absolutely. Now, the content of our data frame has been permanently changed. And, by the way, as you have probably realized already, it is because of a similar information loss that we made a copy of the raw CSV data at the beginning. So far, we altered just df, while the initial data frame, raw CSV data, was left intact. You see? In other words, had we not created a copy of raw CSV data above, assigning it to the variable df, and then had we applied the drop method to the raw CSV data variable, we'd have lost a column from our initial data set. And in case we ever did that, we would have had to load the entire absenteeism data once again. And if the latter seems a small's damage to recover, provided that you could restart the IPython kernel and rerun the entire code up to this point once again, then imagine professional coding files that are hundreds of times longer than this one, and that involves the work of tens of programmers. In that case, forgetting to make a copy will lead to a disaster. In our situation, if we need to return ID back to the dataset for some reason, all we need to do is reassign the copy of the raw CSV data to df and proceed from there. Excellent! This was step 1 in our data pre-processing efforts. Keep the pace for the next video, where we will work on the next column in our table, reason for absence. Thank you for watching.